First of all, very happy to be here. This is my surprisingly my first talk in OWASP New York. I have done a lot of OWASP talks, but never OWASP New York for some reason. If you don't mind, if some of you, I think one of you is not muted and there's a little bit of background noise.
I'm going to mute. That's me. That's some of the guys. I apologize. I'm going to mute.
Sure. Thanks. Sorry about that. Just that not able to gather my thoughts otherwise. Anyway, first of all, very happy to be here. This is my first talk at OWASP New York. In fact, I've spoken at a lot of OWASP chapters at different countries over the years, but strangely enough, never spoke at New York. So I'm very happy to be doing this for the first time. So my talk today is called Tesseract Incursion, Breaking and Securing the Cube. Right. So basically, I'm going to be talking a little bit. This is more like a high level introduction to Kubernetes exploiting and Kubernetes security. Again, I'm not going to be diving deep into too many segments. I'm going to try and keep this under an hour, maybe an hour at best. So I will touch upon Kubernetes. I'm sure some of you know is quite a complex system, quite a large system. It's more a platform of platforms rather than just a platform today. So I'm going to be talking a little bit about both sides of the fence, a little bit of attack, a little bit of defense. I'll be showcasing a couple of demos as well that are, one is attack focused and one is defense focused. So we'll be looking at both these things as we go along today as well. Now, a quick introduction of myself. My name is Abhay. I head a company called V45. Now, we are an application security company, and we're based out of the US, Canada, and India. So we have operations in all these regions, as well as, we do a little bit of work in the Middle East as well. We are an application security, whole and soul, end-to-end application security company. So we only do AppSec day in and day out. So we do offensive and defensive AppSec. Myself, I have essentially started out as a offensive or a pen tester, right? So I started off in pen testing, especially application pen testing, but around 2014, 2015, I started to see the waves of change a little bit. I started to see that the SDL requires a continuous assurance process for application security. We are seeing, multiple deploys. We're seeing the rise of DevOps around 2014, 2015. That's when I started kind of transitioning my role into a little bit more builder than breaker since 2015. So I've been doing a lot more DevSecOps. In fact, I wrote the world's first DevSecOps course. We've trained at several events in OWASP. We've trained at BlackHat. It's been very well received at a lot of events worldwide, especially security events worldwide. Other than that, I do a lot of other trainings as well. In fact, just last month, I'm BlackHat US. We did a Kubernetes security deep dive 2-day training, which was great, which was a lot of fun. And we continue to do this at various events and for private clients all over the world, as well as online classes, stuff like that. Especially with COVID coming in, we do a lot of online training as well. Other than that, I'm also part of a couple of interesting open source projects if you want to check it out. One is called Threat Playbook. Now, Threat Playbook is a threat modeling as code framework. You can check this out. It actually helps you to, the idea here is to help you do threat modeling in a more continuous and more DevOps friendly way, right? A lot of us today do threat models, but the threat models don't really keep up with our application delivery processes. So the idea of Threat Playbook is to kind of create a more cohesive framework that fits in with that DevOps process, right? So that's Threat Playbook. It's on GitHub. You can check out all our projects on GitHub. V45's GitHub. We have a pretty vibrant set of projects that we're working on. Other than that, we also do a lot of community events. We have a YouTube channel where we do a lot of live code events from time to time. We have a pretty well-followed blog, as well as our Twitter feeds, both myself and the company. You can follow, and we keep talking about a bunch of new things, especially on so we are heavily on the DevSecOps cloud Kubernetes side of the fence. So we do a lot of work in that space, especially because we train. And since we train, we do a lot of research and development in that space. So that's something that we do a lot as well. All right. So I'm going to quickly get started. So today's agenda is going to be a gentle introduction to Kubernetes and Kubernetes security. Like I said, this is going to be a high-level talk. I will not be doing too much of deep dive because, again, the knowledge around Kubernetes is very varied, right? So you see that some people have a lot more knowledge of Kubernetes. Some people are just getting started. Some people are somewhere in the middle. So the idea here is that to get a high-level perspective of this space and where I think this is going, right? So that's going to be more my talk today. Well, I'm also going to do, I love threat modeling. So the first thing I'm going to do is a little bit of a high-level Kubernetes threat model. I'm going to talk about some of the key things we're seeing, some of the things we're likely to see, some of the things that have been happening. So aside from the security community, I'm quite plugged into the CNCF and the AWS communities, the cloud communities as well. So I see a lot of, I'm very close to development teams, and I see a lot of this emerging as we go on. So a little bit of that. I'm going to look at a couple of Kubernetes attacks. One of them I'm going to demo, and the other one is going to be some Kubernetes defenses. Again, I'm going to stick to Kubernetes core. I'm not going to get into Kubernetes. Again, so like I said, it's a platform of platforms. It has, you can install and you can run a bunch of services and add-ons and applications that run on top of Kubernetes that can give you an additional set of defenses. So you can add service meshes, you can add you can inject daemon sets, you can do all of that stuff on Kubernetes. But the idea here is that Kubernetes by itself has had a evolving security module. So we're going to look at some of these core Kubernetes defenses, and we'll also do a quick demo on one of them at the end of it. And I'm going to be doing live demos, right? So live demos are always risky, always fraught with danger. So please pray to the demo gods for me. Live demos are always a little nerve-wracking, but I'm hoping that they go well. So that's essentially my piece before I get started. So let's get started with a quick introduction of Kubernetes. So I like this. In fact, after the talk, I'm going to share the slides, and you can probably get to the URLs that I've sourced. So I like this description about explain Kubernetes like I'm 5. So in this, in fact, the article is very nice. It's a very easy to understand article, especially for people who are so Kubernetes, once you think about Kubernetes, you think about it as this big system that has a lot of moving parts. So let's kind of break that down and make it a little simple for everyone to understand. So Kubernetes, so think of a Docker image. So everybody is probably used or is probably familiar with a container image, right? So a Docker image or a container image is essentially like a blueprint for a cow. So that's basically the story that the author says. So blueprint for a cow is a container image. A running instance of that blueprint is your container itself, right? So when that image is running in a node somewhere, in a VM somewhere, on a machine somewhere, that is an instance of a cow that's actually running on that instance somewhere. Now, essentially your node, so let us say you're running a bunch of containers on your laptop, or let's say you're running it on a server somewhere, that's a corral, right? So a node is a corral, and you have a bunch of corrals. So let's say you're a large company and you have a bunch of nodes that you are managing as a cluster, and you want to obviously orchestrate all these containers, these cows, in an effective way and make them work together, make your workloads work together. And you need a rancher, obviously. You need a rancher, and that rancher happens to be Kubernetes, right? So that's basically your very, very simple breakdown of what Kubernetes actually is. So you have your corrals, which is your nodes, you have your containers, which are your cows, and the rancher essentially manages and orchestrates and controls the entire end-to-end life cycle of these cows and these corrals. So that's basically what Kubernetes is. So Kubernetes is not the only one that does this. You have a bunch of products that do this as well. Kubernetes just has happened to be the one that has kind of taken off, right? And there are some reasons for that. So Kubernetes so there are other ones, like there's Mesos, there is Nomad, there's Swarm, there are multiple container orchestration platforms. So the real reason why container orchestration platforms really became important and have become so critical is because containers as a technology itself has become critical, right? So previously, packaging applications was a complicated thing, and you would always end up breaking something because there would be a dependency missing or something would not have been installed on the base operating system. As a result, your application deployment would crash. So a more structured way of doing it, more friction-free way of doing this, excuse me, is essentially with containers, because in containers, you're essentially packaging your app, its dependencies, and all of the code that you need to run it in this container image, and you're deploying these containers on your nodes, and you're orchestrating and running them. So that's basically what you're doing. And as a result, you're able to scale it much faster. So let's say you want a replica of, let's say you want 100 replicas of your application server or your web application running in production. You can just do that like this because you have something like Kubernetes that's orchestrating it for you, right? So that's basically what container orchestration systems do. So under the hood, you're essentially, all these container orchestration systems are essentially allowing your apps to be deployed, apps to be scaled, apps to be accessed by different users. In fact, they also give you a lot of networking and gateway ingress capabilities that allow your apps to be accessed by specific sets of people as well. So if you kind of go into the advanced variants where you're looking at service meshes like Istio and stuff like that, you can actually do a lot more fine-grained gateways. Like, so for instance, let's say somebody is accessing your API and they come in with a particular JSON web token, you can route them to this particular API. You can validate that through the service mesh. You can do all of that stuff. So container orchestration is one aspect of it, but really managing networking, managing compute, managing the overall life cycle of your application in prod or in any other environment that you can think of is essentially what Kubernetes or Mesos or Nomad or any of these things help you do, right? So Kubernetes, essentially, this is a kind of a, I would say this is a high-level diagram of what a Kubernetes deployment looks like, right? So this is what a cluster looks like. So the blue part of this diagram is essentially the control plane, or essentially the Kubernetes, the components that manage the cluster. So essentially what we have here is a cluster, right? A cluster essentially consists of a Kubernetes control plane and all the worker nodes that essentially run the actual workloads and actually where these workloads are actually running off the cluster, right? So the control plane essentially, like I said, is the component or a set of components that manages the cluster, or through which you can manage the cluster, right? And one of the fundamental components is the API server, and this is the component that all of us talk to. So if you have done anything with Kubernetes, if you have, and we look at this in the demos as well. So the API server is essentially what you are talking to as a developer or as an application. Essentially, what you're doing is facilitating access to the API server. The API server, as the name suggests, kind of manages the deployment, kind of initiates the actions for the control plane to take. So you can say, hey, API server, give me 5 replicas of Nginx. So API server would talk to the controller manager that would say, hey, I want 5 replicas. This would talk to the scheduler that would schedule all these different Nginx pods in different worker nodes, and essentially you would have 5 replicas of your Nginx service running in pretty much no time, right? So the API server kind of is the conductor, the orchestrator of the whole show. Of course, you have other components that are running in the control plane. You have the controller manager, which essentially controls all the other controllers. So it controls replication, it controls service accounts, it controls all of the other different management services that you have. The scheduler essentially is responsible for deploying or orchestrating workloads into different nodes, right? So let's say you want to deploy an application into your cluster. The scheduler ensures that these applications are deployed into specific nodes. It figures out which node it has to use. It figures out whether there's any specific requirement for a node. So let's say your application is a machine learning application and you need a particular type of node with a GPU, or let's say there is a specific hardware requirement for that node. the scheduler would deploy that application based on your specification to a particular node with a higher GPU or something like that, so that that application runs smoothly. Of course, you have the database of the entire cluster, which in this case is etcd. So etcd is the key value store that stores all the configuration, the running parameters, the running configuration of the cluster stored in etcd. That has also traditionally been a source of attack, although not so much today. It's been lots of these attacks have been plugged because a lot of these components over time have been hardened by the Kubernetes project itself. But previously, in fact, when Kubernetes was just starting out and the earlier version of Kubernetes, you would see all of these components were easily subject to exploitation, right? You could just directly access etcd, you could directly access the node and then start running commands on the node and do all kinds of stuff. So it was kind of the wild, wild west about 2.5, maybe 3 years ago. But now over time, Kubernetes themselves have added a lot of security features and have hardened a lot of, they've resulted to a lot of secure defaults for a lot of the components that are running in the control plane and on the nodes. When it comes to the node, you have some components as well. You have the kubelet, which essentially is like the controller for the node, right? So let's say you have 50 nodes. Obviously, these nodes need to have some kind of an orchestration system that would run these containers and manage these containers in that particular node. That is the kubelet, right? So kubelet does that job of orchestrating and running things in that specific node, right? This has also traditionally been a subject of attacks as well. So kubelet runs on port 10.250, and in older Kubernetes deployments, it was essentially no access control. So you just access REST API on 10.250. You could literally run any command you want or any kind of payload on that particular node. So this was a huge attack, which has now, of course, largely been plugged for the most part. I'm just checking if there are any chat messages.
Hey, well, if we'll get questions. Zoe and I will collect questions for you and hit you up.
Oh, perfect.
If we see them or towards the end, okay?
Sure, perfect. Yeah, that makes sense. Yeah, it just makes it easier for me. Thanks. Right, so you have the kubelet, you have the kube proxy, which is like a network component, which allows you to expose certain services. So let's say you have a Nginx service, and obviously Nginx is a web server that you might want to allow some other services to talk to. So you might expose that service outside of that particular node through the kube proxy, right? So you can proxy it so that other users can access that particular service. And of course, you have the cAdvisor, which is really the metrics engine for the node, right? So that collects details about, hey, what is the resource utilization on this node? How much CPU is being utilized? How much memory is being utilized? What's the disk, et cetera, so that this keeps talking to the API service and the control plane, so that the control plane realizes that, hey, this node might be kind of running on capacity. So let's start to orchestrate things on another node or some other node. So essentially, this is like a fine-tuned distributed system where the control plane kind of orchestrates it from the global level, but within the nodes, there are some components that also run and give you metrics and give you an understanding of what's happening within the node. Of course, Kubernetes has a bunch of deployment options, right? So the most simplistic and the lowest level deployment option is called a pod. Now, a pod is a set of running containers, right? So it doesn't have to be one, it can be one container or more containers, but typically any set of running containers is a pod. So let's say I have a simple application. So let's say I have a Node.js web application that talks to a MongoDB database. And this, let's say that's a very small application, and I don't want to obviously, let's say I don't want to replicate one instance of this, or just the application, let's say 100 times, or just let's say it's a small application that's used by 100 people or something like that. In that case, I might decide that, hey, I want to run both these things, so the Node.js app and the MongoDB database, in a pod. So which means that it runs two of these containers in a pod. It gives them the network, and you can talk to the Node.js application that would talk to the database. All of this is running as a pod, right? Each pod has their own has its own network address, and the pod has an internal networking. The pod can also talk to other pods depending on the configuration that you set up in the cluster, and so on. So that's basically how pods work. Now, besides pods, you also have different types of deployment options. You have the deployment object that helps you create replicated, more streamlined deployments of the same pod. So let's say you create a deployment, then you can say that, hey, I want this pod, but I want 5 replicas of this pod. And whenever a version changes, let's say I deploy a new version of this application, I want a clean rollback, or I want a clean update process where I say that I'm not going to bring everything down and then update it, but I'm going to update it over a kind of a rolling system of updates. So I can do that with the pods through different types of deployment objects. And Kubernetes, one of the key things with Kubernetes is the plugin network, right? So you need a network plugin. So Kubernetes by default doesn't come with its own network plugin. It has a very basic network, but if you want additional networking capabilities and APIs, you need to deploy a networking plugin like Calico or Cilium, Kubernetes, and so on. That helps you do things like firewalling. It helps you do things like policies. It helps you do things like in terms of how the network should flow, the network capabilities, and the kind of supported protocols and so on and so forth. So that's the role of the network plugin. Right. So let's quickly talk about the Kubernetes threat model. Again, like I said, I'm just doing a high-level Kubernetes overview, and I'm going to get into the threat model. Now, in Kubernetes, most of the issues that we see, most of the issues that we see with Kubernetes happen to be with the misconfiguration of the cluster. Now, when you look at the cloud security model, so let's say you are running AWS or Azure or GCP or what have you, and you look at the Kubernetes model at a conceptual level, you are pretty much dealing with a same set of things, right? So in AWS, one of the biggest challenges that you face is excessive privileges being given to a particular component, or excessive privileges being allocated for a particular resource. And let's say that resource get compromised. So let's say I'm running a web application, and that web application is running on my Kubernetes cluster, but the user that has configured or that has deployed that web application happens to be a cluster administrator, and you misconfigured it in some way. Then the attacker who compromises that web application now can potentially have a path to my entire cluster, can privilege escalate to my cluster. So in most cases, it is misconfiguration and excessive privileges that cause exploits and compromises of your Kubernetes cluster. So breaking it down into a one statement. So if you want a single statement kind of a threat scenario, in most cases that is what is causing your Kubernetes cluster to get compromised, right? So it's misconfiguration of the cluster and excessive privileges that lead to additional privilege escalation and lateral movement possibilities. Of course, you have different security options that you can use to plug these security issues, but the idea here is in most cases, the reason why it starts or the initial attack vector is largely because of these misconfigurations and excessive privileges. So for instance, things like this. So your malicious or compromised pod. So let's say I'm running an application, an adversary compromises that application, and through that gains access to the cluster and privilege escalates within the cluster. Or let's say you deploy some additional add-on service on top of Kubernetes. So Kubernetes is a very extensible and a very, very powerful distributed system. So you can write your own APIs, you can create your own API groups, you can create your own API resources. Now, let's say one of those resources has been created in an insecure way, or one of those resources is vulnerable to some application attack, let's say deserialization or XML external entities or what have you, then that could also result in privilege escalation to your cluster. Kubelet historically has been a major butt of attacks as well. So Kubelet has been, there have been scenarios where the kubelet, which is running on the node, has been compromised. And as a result, and that has escalated privileges to the cluster as well. Previously, this was an unbridled access. So if you compromise one of the worker nodes, the kubelet component running in that worker node had access to the entire cluster, which was unnecessary. So previously, older clusters, if you're running older clusters, If you compromise the kubelet, it would typically result in the compromise of the entire cluster, which was a really bad security model, which has now been plugged, but a lot of us still run older clusters. In fact, one of the biggest challenges with Kubernetes that I see, especially out in the wild with my customers and with a lot of my students that take my class, is that in Kubernetes, one of the key challenges is that you have newer security features being released with every version. But that does not mean you can easily just patch and move on, right? Because you would have created very custom resources for that version. You would have created deployments that work with that version. Your add-ons, your extensions, all of that would be optimized for that version. Now, if you have to change that and patch to a newer version, you have to obviously migrate all of those resources, all of those deployments, all of those things that you have orchestrated in the older version of Kubernetes. So as a result, you see that managing the cluster is a little bit of a challenge. You definitely have to think about these things before you just migrate over. So although the state of Kubernetes security has been improving since the time it launched, there's definitely one of the things that you should keep in mind is that you have to manage the migration to a newer version, because all of these testing aspects of it, the reliability aspects of your cluster, come into question at that particular point in time. So let's look at some real world attacks that have happened. So one of the big ones that happened just this year was the Kubeflow crypto mining attack. So Kubeflow was a machine learning application that is deployed. So Kubeflow is essentially I'm sure some of you have heard of TensorFlow. So TensorFlow is a very popular deep learning, machine learning library from Google. Now, Kubeflow is essentially TensorFlow deployed, made easy in terms of its deployment on Kubernetes, right? So you can essentially deploy your deep learning apps or your machine learning apps on Kubernetes, and Kubeflow makes that happen. Now, this was a very low-grade attack, but it kind of entirely compromised a whole bunch of clusters, including those on Google, on Azure, on Amazon, on all of what have you, right? So what happened here was that Kubeflow has a dashboard. And the dashboard, so essentially Kubeflow is this application that's running on top of Kubernetes. And what you can do with Kubeflow is you can use Kubeflow to deploy your own machine learning apps, right? So you can just deploy your own machine learning applications through Kubeflow. So it's kind of a platform that manages other platforms. So Kubernetes, like I said, platform of platforms. Kubeflow is a platform that helps you deploy your apps, creating a platform for machine learning apps. So Kubeflow had this dashboard that was without authentication and that was running externally. So as you can imagine, bad things happen when you're running dashboards without authentication. And Kubeflow had that, and you had thousands. Even now, if you look at it, you'll still find a bunch of, if you go on Shodan and look for Kubeflow by certain headers, you can actually see that there are a bunch of Kubeflow Kubernetes deployments that are running dashboards without any kind of authentication. So at that point, it's not even hacking, right? So attackers naturally leverage this to start running crypto mining code, and started leveraging people's compute to start running their own crypto miners with Kubeflow. So this was a pretty big attack. In fact, Azure, we were running a bunch of labs for one of our customers, for a training for one of our customers about, I think, a month back. And Azure, a month or a month and a half back, they still had this flaw, and then they patched it within 2 weeks. So we had to rewrite that lab and do something else with it. But you actually had this very much out in the wild for a while, and it was just this year as well, just in June this year. Other than that, the other potential type of attack that you could see is also with the Kubernetes API. Now, remember, Kubernetes is also a pretty large system, and it can also have flaws. So just like any of your commercial components or any of your open source components have flaws, Kubernetes also tends to have its own set of flaws. This is not as bad as you would think, right? So let's say you're dealing with a struts framework or something like that, that has a ton of flaws, but Kubernetes thankfully has not had that kind of security issue. So it's largely been avoided. So, but you still had some of these issues. So Kubernetes had a vulnerability called a billion laughs attack vulnerability, where you could reference. So Kubernetes, the way you deploy Kubernetes workloads is through YAML, right? So you essentially create YAML, and this is called a manifest, right? So you create a YAML manifest, and you deploy that manifest in Kubernetes by just saying kubectl apply-f this particular manifest. What happened in Billion Labs is that you can create a recursive YAML specification that calls itself over and over and over and crashes the Kubernetes API server. So this was a pretty serious attack that was late last year, about the same time last year. This was a pretty serious attack as well. So like I said, common Kubernetes security issues, misconfiguration of the cluster, access control configuration of the cluster is always a problem. It's always a problem. This is the big thing. The other thing that people tend to ignore, which is also a very important thing, is your containers itself, right? So imagine that you're running an application in a container, and that container is running with root privileges, it's running with a lot of insecure stuff. Then it results in weakness, because if that application is compromised, now that container is compromised, and that can lead to a privilege escalation, a path for lateral movement within the Kubernetes cluster. Of course, a lot of times people are not aware of the security features on Kubernetes itself, which causes a lot of security issues within Kubernetes, and lack of host hardening, and vulnerabilities in core components, and so on and so forth. All right. So with that, I'm going to quickly do a offensive demo of Kubernetes, right? So let's talk a little bit about what I'm going to do in this demo. So this is our demo setup. So I have a Kubernetes cluster, and I've deployed web app with a Python web app and a Redis database that is essentially being used as a database for that web app. So it's a Python web application and a Redis database, right? So this is running as a pod. Now my idea here, and so let's say I'm an adversary, I want to be able to compromise this infrastructure. So I happen to know through some way that this Redis database contains a bunch of credit card numbers, and I want to compromise these credit card numbers. So that's my objective for this attack, right? So what I'm going to do as an adversary is I'm going to try and compromise the web application itself. And after I compromise the web application, I am going to try and escalate my privileges to the Kubernetes cluster. Once I escalate my privileges to the Kubernetes cluster, I am going to create a malicious Redis pod. So I'm going to deploy my own Redis pod. Now, Redis has this capability that you can say that, hey, you know what, so you can deploy a Redis instance and say that, hey, you are the mirror copy or the secondary database of this primary database. You can say that, hey, connect to this primary database and just synchronize all the data. So this effectively becomes a secondary copy to that primary database. So what I'm going to do is launch my own attacker-controlled Redis pod, and this pod is going to add itself as a secondary database to the Redis database, and then pull out all the data and exfiltrate all of that data to my attacker controlled listener. So that's what I'm going to be doing. So let's look at this attack as we go along. So this is from our training class as well. So I've already set up my cluster, and I'm just going to get started with my attack. So I've already set up my cluster. I'm already running a bunch of applications. So kubectl get pods. So you see my application is already running. I've created 3 instances of this, and I've also created a bunch of services. So this is kubectl.
Abhay, are you supposed to be showing us something right now? Because we're still on the PowerPoint.
Oh, really? I'm sorry. Let me just change my share. I'm sorry about that. I didn't realize that.
I gotcha. Great.
Can you see my screen with the command line?
Yes, 10-4.
Oh, thanks. Perfect. Sorry about that. So yeah, luckily I had not gotten too deep into the demo.
Yeah, you want to go over what you just did? So no one misses that?
Yeah, so I've already deployed my Kubernetes. So this is a running Kubernetes cluster, and I have deployed my app, right? So my app is a Flask Python app, which is backed by a Redis database. That's it. It's pretty simple. That's all I've done so far, right? So the app is running on port 80, and my Redis database is running on port 6379, which is the default Redis port, right? So that's really it. Nothing else has happened so far. So I'm just gonna, so if you look at what I'm gonna do, I'm just gonna set up some environment variables. This is just for me to talk to my application. So I'm just going to set up some environment variables. This is not material to the actual demo. So I'm just going to show you what this means. This is just going to give me a URL for that application. So it says that, hey, when you want to talk to the application, you need to make your web request to this particular IP address. So since this is a cluster, it's a small cluster, I've not exposed this to the outside world. This is just for my demo. So that's why it's an internal, a private IP address. But imagine that this was an external IP address. It would be the same, same orientation, same example. Right. So I'm going to initialize the application. So I'm going to initialize the application. It says, hey, you know what, so this is like a transaction processing system which processes credit card transactions. So it's just a very, contrived demo application that we've created for this. Right. So the idea here as an adversary that I want to do is I want to be able to access so I want to gain access to all these credit card numbers. So I'm just getting the status information from my application, and you can see that my credit card numbers are truncated, right? So my credit card numbers are truncated. The idea here is that I want to get access to all these credit card numbers. And for that, I need to probably compromise the database. I probably need to compromise the database for this to happen. Now, this application has a vulnerability called a YAML deserialization flaw. So the way it works is, let me just give me a sec. Let me pull up a slide to show you what that deserialization vulnerability looks like. Just give me a sec. One second, so that I can just pull up that and explain what that looks like. Yeah. Just going to start sharing again. So yeah, so this is an insecure deserialization flaw that we are going to exploit in order to privilege escalate to our cluster, right? So insecure deserialization is essentially a very common flaw that happens with any serialized formats, or can happen with any serialized format. So let's say you have serialized formats like JSON or XML or YAML or TOML, or you have several formats. You have formats that are specific to a language, you have formats that are agnostic. So essentially, insecure deserialization is like a embedded explosive, right? So let's say you have some object that you're serializing. So let's say you're serializing a YAML. Now, aside from the YAML or the JSON, you embed some malicious code or some object code that you want the parser to parse, right? And you send it across to the machine that is loading this or processing this, or the application that's loading this or processing this. Now, the application reads this and just unpacks or deserializes that serialized object. So it takes the serialized object and obviously needs to convert that back into object code. So it deserializes this object and then finds this malicious code that blows up in the application. Now, whatever is this malicious code could be a authorization bypass, it could be a remote code execution, it could be any one of those things, right? So in this case, it happens to be a remote code execution payload. So we are going to trigger that in our application and then use that to kind of privilege escalate into our cluster. Right. So we have just so far, we've not done any of that yet. So the first thing I'm going to do is I'm going to run some deserialization payloads to check if it works. So let's look at the first payload that I'm going to run. So the first payload that I'm going to run is this. So this is a YAML serialized format, except that you'll see that line number 2, you will see that there is a completely, doesn't look like a normal YAML value, right? So you have keys and values. The first one is a random key and value, second one random key and value, whatever it is. But the reason key has a very weird kind of a value. So you see that it says, hey, Python object apply subprocess check output print TMP. So our objective as the attacker is to try and see if this application is vulnerable. And if this application is vulnerable, it is going to execute this printenv command on the backend operating system and actually parse it, right? So it's actually going to run this command. So this is remote code execution at its finest. So you can actually see that if this works, you can run pretty much any command on the backend application that you are targeting. So we're going to do that, and we're going to try and see if this works. So I'm going to upload this YAML file to my application and see if it works. So seems to have stored, but let's see whether it actually works. Now, when we look at the status of the previous transaction, which is what this is, so it considers each YAML a transaction. And if we get the status of the previous transaction, you'll see that, a huge dump of our environment variables have now been dumped in our database. So which means that our payload is actually getting processed. It's actually working, which means that our serialization attack is working because it's dumped the environment variables for that container on our in the database. So it actually has processed it and it's dumped it into that database. So now we can actually start doing more interesting things with this payload. So I'm going to set up a reverse shell. So I'm going to do a reverse TCP shell. So the reverse TCP shell is very similar just like I set up the previous YAML, I'm going to set up a single line reverse TCP shell. So what this is going to do is it's going to drop a shell in that container, in the application in that container, and then it's going to connect back to my attacker listener that is sitting out there on the internet somewhere, right? That's what this reverse TCP shell is doing. So what I'm going to do is open up another terminal, and I am going to set up a netcat listener. I'm going to set up a netcat listener on port 1337. I'm also going to modify my reverse shell to be to connect back to my IP address, right? So we want it to connect back correctly. So I'm going to do that. And I'm going to upload this. So if this, I'm going to actually push this YAML to my vulnerable application. If it works, it's going to connect back to my TCP shell. So upload, hoping it works. Looks like it's connected. Yeah. So we have our reverse TCP shell. So you can see that now I am talking to the application. So I'm able to access the shell environment from within that container, that application running inside a container somewhere in a Kubernetes cluster. So I still don't have access to the cluster itself, but now I am in that application, and now I can start to escalate my privileges within that cluster. So that's really what I'm going to start doing, right? So one of the things you will see at Kubernetes, and very popular privilege escalation technique, is to get into this. So in many cases, not always, of course, but in most cases, until I think late last year or even early this year, where they introduced a security capability where this does not happen. But in most cases, the account that is used to deploy that particular container has a token injected into this path. So run secrets Kubernetes IO service account. So when you look at this particular path, you have the JSON web token for that particular account. And if that token happens to be of a user with sufficiently high privileges, you can actually start to now access that cluster as the owner of that token. So in this case, the token, in this case, it happens to be that the account that deployed this application to the cluster has cluster admin privileges. And a lot of times you will see that this is a very common state. You will think, how can somebody do something so silly that deploy something with cluster admin privileges? A lot of apps do it by default. They deploy stuff with cluster admin privileges. And that is what is injected into this container, right? So I'm going to, if you look at the token, you'll see that this belongs to a service account. And I happen to know that this service account is a cluster admin scoped service account, which means that this has the administrative privileges on that Kubernetes cluster. So now I can start to actually interact with the cluster. So let's first export that as a environment variable. And now I'm going to start escalating my privileges to the Kubernetes cluster itself. So remember, Kubernetes is, I'm going to be talking to the Kubernetes API server, which means that it's a REST API. So I'm just going to use the REST API to start gaining access to the Kubernetes API. So what I'm going to do is I'm going to copy this. So you see that what I'm doing is I'm saying, hey, get me all the pods that are running on the Kubernetes cluster. I am the user who's the bearer with this particular token, and this token, like I said, happens to be a cluster admin, and I'm accessing all of that. So when I run this, you will actually see that it gives me all of the pods that are running in this particular Kubernetes cluster. All of the pods that are running in the cluster is now available to me. I can start stuff, I can stop stuff. At this point, I am completely in control of that cluster, right? So I have complete access to the Kubernetes cluster, and I'm able to do pretty much anything I want to with that cluster at this point, right? So this is something I can do. So now what my objective, remember, my objective is to steal credit card numbers. So I'm going to add my own malicious Redis pod to the Kubernetes cluster, which means that first I have to find the existing Redis database, say essentially create a configuration so that my malicious Redis database becomes the secondary database for this existing Redis database, and then starts to exfiltrate data to my listener out on the open internet, right? So first I need to find my Redis database and which service it's running on. So I'm going to fetch that service. Again, since I'm cluster admin, I can start fetching anything I want. I can fetch secrets, I can fetch services, I can fetch anything I want from here. So I see that, hey, this is the services and this is the Redis service. I'm just going to copy the IP address for the Redis database. I'm going to copy that over, and I am going to quickly paste that in a new file, just a file so that I don't lose access. I don't have to do this again and again. And yeah, so basically I have access to that. Now I am going to set up my malicious Redis pod. So the first thing I'm going to do is get my internal IP address, and I'm going to copy this over as well. And I am going to create my malicious Redis application. So the first thing I'm going to do is copy some JSON, and I'll show you how I'm going to set that up. So here I'm going to, this is my malicious Redis pod specification. So this, what it's going to do is as soon as it launches on Kubernetes, it's going to add itself as the secondary database to the primary Redis database. And it's also going to connect to my attacker listener sitting on the internet. So in this case, the listener also happens to be the same IP address. So I'm just going to set up that host information pretty quick. So this is the first thing that I'm going to do. And the next thing I'm going to do is copy over this data set here. Yeah, so I'm going to just copy this much, and I'm going to paste it in my shell that I have. Paste it here. Oh, I need to be in a different directory. Sorry about that. Just give me a sec. So I'm going to be /temp, and then I'm going to paste it in this. And now I'm going to run that pod. So far I've just created the malicious Redis specification. Now I'm actually going to run that malicious Redis on Kubernetes. Okay, I'm going to run it on Kubernetes. So I'm just saying, hey, you know what? Deploy this JSON which contains the specification for my pod on the namespace in the Kubernetes cluster, and that's it. So if this works, it says, yes, I've started to deploy it. Give me a few seconds, and I'm going to pull up the container. I'm going to start deploying it. Now I'm going to set up my attacker listener and wait for some communication, right? So I'm going to set up my attacker listener, and my malicious Redis that I've deployed should start to feed me credit card info anytime now. As soon as it's deployed, it's going to connect to my attacker listener, and it should start dumping that credit card data anytime now. So I'm just, yeah, you see, it dumped. So in this case, it dumped all the credit card transactions. So it dumped a bunch of, in this case, there are some 10 transactions, but imagine that it was a larger database. So this is a very classic card breach, right? A lot of the card breaches have had this kind of a system where the attackers have compromised the system. Then instead of actually just doing a single compromise, they've actually persisted and they've pulled out data over months and years sometimes. And this is how you could do this with Kubernetes itself, right? So what we did was we
Abby, so this is all because you installed another Redis database or and connected to the master, and you were able to take over as admin or had escalated privileges?
Yes.
Wow. Yeah, Abhay, I have a question that why you had to use the insecure flag?
I'm sorry? Insecure flag because this is a self-signed certificate for the Kubernetes API, right? So this is so Kubernetes API that I'm using, I'm just using a test cluster, right? So it's not signed with a CS cert, a CS cert like Google or AWS. It's a self-signed cert. So that's why the -- insecure.
Makes sense.
Yeah.
I have like a couple of questions if you don't mind, if it's a good time to ask. Just like your OWASP top 10 itself, right, which talks about different vulnerabilities at your code level. Is there any a data set that's available which talks about vulnerabilities that can be exposed in the containerized world itself? And is OWASP or like any other standard which is going to like talk about these aspects?
I don't think there's a unified project like that yet. But yeah, it's an interesting thought. I don't think there's a unified. There are benchmarks for container security, like CIS benchmarks and stuff like that. That's more for the security side of it. But I think you're referring to a list of attack vectors and attack outcomes. Is that what you're looking at?
Yes.
Not that I know of. I don't think there's any unified problem.
And in fact, there is one more question that I have. I mean, like when you talk about like third-party vulnerabilities, right? There are a lot of open source sites that you can actually download vulnerabilities like CV, MVD, all those information, right? Do we have a similar open source, not like commercial one? Like most of the data sets you can actually get from Arco and Twistlock and any other solution, right? Are there any open source databases that you can get all these things and scan based on known vulnerabilities?
I mean, known vulnerabilities. So in this case, the vulnerability happened to be in the application first, right? So if you scan for insecure deserialization, or if you're doing some kind of tests for insecure deserialization of your app, you would have found this.
Yeah, correct.
So that's point number one. Point number two, you can scan your Kubernetes cluster for security issues, and it will tell you that, hey, you're using cluster admin to run these pods. So there's one called Kube Audit. That's an open source tool that can help you find this kind of stuff.
So Kube Audit is a good tool to run while you're writing and developing your application.
No, that's more an infrastructure tool. So you might want to run that. You can run that in CI/CD, but if you want to run that, ad hoc as well, you can do that.
Okay.
So it essentially gives you a bunch of different checks that it does, and it tells you that, hey, your Kubernetes cluster is vulnerable to this, but it's fine with this, that kind of stuff.
Kube Audit. Excellent. Thanks.
Yeah. Cool. So I'm gonna move on because I have a little bit more to cover, and I think I'm already running short of time. So this is how you can escalate privileges on your Kubernetes cluster, right? So it really is a matter of doing something like this to be able to escalate privileges on your Kubernetes cluster. So just give me a second. I'm just gonna set up my other image as well. In the meantime, So So what we did in this case was that we were able to compromise the cluster, add our own pod, and through our pod, exfiltrate a bunch of credit card numbers, right? So this can be used in different ways. You want to bring down something, you can do that. If you want to add crypto mining, like a lot of attackers do today, you can do that. the idea here is the outcomes are not important. Whatever is the attacker's outcome can be achieved with this sort of attack. And there are different types of channels that can lead to this attack, right? So once you compromised an application within the cluster, it really becomes about what privileges that particular application or that container has, or what kind of account that it's been provisioned with, that can result in these sort of privilege escalation possibilities and lateral movement possibilities in Kubernetes, right? So this is something that happens, and this is quite common. In fact, a lot of applications, I mean, I'm sure people who have been dealing with containers as you know, for their work, will probably see that a lot of containers that you're dealing with probably still run as root, right? A lot of them still run with root, probably a lot of them required to be run with privileged. You have a lot of those challenges that you're up against. So sometimes this is, you know, it's not as easy to prevent as you think. But today you do have some Kubernetes controls. You have the service account mount and stuff like that. You can set up to say that, hey, don't mount the service account token on this particular container, so that even if that container is compromised, the attack surface or the attack blast radius is restricted to that particular container. It does not suddenly become a bigger thing. So the other one that was also a pretty famous attack was Helm 2, right? So Helm 2 essentially is a package manager for Kubernetes, right? So Helm 2, the way it used to work was like this. So just like you have apt-get install for Ubuntu, Helm 2 was the apt-get install equivalent for Kubernetes, where you essentially create deployment manifests as chart files, which is again YAML. And what used to happen was that your client used to interact with a gRPC service inside the cluster called Tiller. And this Tiller would actually deploy your Helm deployment, your Helm files and your application to the Kubernetes API. However, this Tiller was running with service account cluster admin privileges. So a lot of times, if you just contacted Tiller, either internal or outside the cluster, you were able to completely do anything with that particular cluster, because Tiller gave you access to deploy anything, run whatever you want on that particular cluster. So Helm 2 has now become Helm 3, and what they have done is that they've removed Tiller so that it becomes a little bit more secure, and you as the client have to directly deploy into the cluster and not go through that previous that mediator service called Tiller, which had cluster admin privileges. So now whatever privileges your client has, only those privileges are inherited when you are deploying your Helm packages on Kubernetes. So this was a pretty huge attack. In fact, in our trainings, we cover this as a pretty large red team exercise as well. So you can, so I'm not going to be able to show that because we're already running a little bit out of time, but this is a pretty interesting attack that we see even now. When we do a lot of pen tests, we still see this happening quite a bit on Kubernetes. Right. So so Kubernetes, let's talk a little bit about security principles. Now, again, so Kubernetes is like I said, it's a distributed system. So your defense has to keep that in mind, right? You can't look at only perimeter controls and stuff like that. You're typically doing a lot of microservices style deployments. You're typically doing a lot of distributed deployments. Your security has to scale. So you need to ensure that your security, the kind of security that you're deploying on that cluster also adheres to the distributed nature of the system. So don't think of too much perimeter controls. Think more about, hey, localized controls, decentralized controls, things like authorization controls on that API, network policies for this API to talk to another API. This kind of stuff makes a lot more sense. And as much as possible, automate your security controls, because once you start increasing your scale of your cluster, it becomes really difficult to manage it with a purely manual kind of an analysis. So definitely look at automating your cluster security controls. So when you're looking at your Kubernetes security, you do have stuff that runs on top of Kubernetes that can help you secure it. So Istio, some of you I'm sure have heard of Istio, which is a service mesh technology. Now, Istio, apart from being a service mesh, also provides a bunch of security features like authorization, mutual TLS. It gives you a lot of security capability. There's also a very interesting project called Open Policy Agent that helps you create policies for your cluster. So you can say that, hey, do not launch any pod into this cluster, which is if it's running as privileged, or do not launch any pod into this cluster that has sensitive environment variables, hard coded. you can create policies like that, and your cluster automatically starts enforcing these policies on your users. So even if your users, even a cluster admin privileged user, if they try and deploy non-compliant resources into the cluster, it would not allow it because your open policy agent would deny that based on a certain set of policy rules. It's always a good thing to do this. Kubernetes by itself comes with its own security controls, right? So you have authentication, access control, you have all of these different things that you can run as part of your Kubernetes core security itself. And of course, you have to look at the supply chain aspect of it. So containers are very important. So if your containers are vulnerable, that could lead to your Kubernetes cluster getting compromised. So even though you might have put great controls on your cluster, you still have a potential exposure or a potential point of compromise in your cluster because your container is vulnerable, your application is vulnerable. That still is the biggest cause of attacks in your Kubernetes cluster. In the cloud, the same thing applies. Now, a lot of people have this misconception that just because you deploy or you run workloads of Kubernetes in the cloud, they take care of all of this for you. That's not true. They do take care of some of the stuff for you. So every cloud provider has a shared responsibility model, right? So you need to understand what that model is, and when it comes to the Kubernetes service that they have, where that model stops. So it typically stops with the control plane, right? So they don't let you mess around with the control plane, but they still, aside from that, the authorization, the privileges, the secrets, the logging, the access control, everything is still your problem. And privilege escalation is still likely to happen. In fact, it's very likely to happen even in a cloud managed Kubernetes service. So please do not assume that just because you're running Kubernetes workloads on the cloud, that it's super secure, I don't need to worry about it, they take care of everything. That's not even close to being the truth. So please think about that when you're getting into the cloud. So I'm just doing a high level analysis of the Kubernetes core security features, very high level. Again, this is the reason I'm saying very high level is because Kubernetes, the ecosystem, by the time I'm done with this talk, there's probably a new Kubernetes security tool that's released. So I'm just saying it's a very vibrant ecosystem. Things are changing all the time. So this is just the core set of controls that Kubernetes provides. Kubernetes gives you a lot of controls for authentication, gives you the typical ones are your service account with JWT, certificate. So when you're using Kubernetes as a user, you're typically authenticating with certificates. It gives you different types of access control models, role-based. Role-based is the default that ships with Kubernetes, but you can also enable other ones. So Kubernetes also gives you another abstraction called admission control, right? Now, this is a very important and probably the most critical security abstraction in Kubernetes, because when you have an authenticated authorized user, but admission control essentially enforces a certain set of rules that people can't do. So let's say your user is trying to deploy a privileged pod on your cluster. So he's a cluster admin trying to deploy a privileged pod on your cluster. Admission control would prevent that from happening, right? So it would have a bunch of additional access control rules that would prevent certain types of workloads based on certain types of rules and policies to be deployed on your cluster. So that is something that you can do. And this is a very important aspect of Kubernetes itself. And of course, you do have a lot by way of encryption. You can use custom encryption providers like AWS or Vault or one of these encryption providers. And you can also do a lot of network security in the form of network policy. And if you want something a little bit more advanced, you can go with Istio and service meshes and stuff like that as well. So these are the, like I said, the core Kubernetes security capabilities. Again, like I said, you can build on top of each of this with a lot of custom stuff. You have products that are both open source and commercial that can help you leverage this stuff to the hilt. You can add OAuth bindings to your Kubernetes cluster with, if you're using Auth0 or Cognito or what have you for authentication authorization. You can do a lot of customization and extensibility on top of it. These are just the core features that it offers. Do I still have some time, or are we running short? Just want to know from.
Yeah, we still have some time, but I just want to let you know that I've sent you some questions in chat. I have a few more that I'm going to be sending you in a second.
Okay. Do you want? Okay. Let me just finish my demo and then take that question. Those questions.
Yeah.
Is that okay? I have one more demo.
Definitely. Yeah. No, go over the demos. Definitely, please.
Cool.
This is good. This is
I'll just finish. Cool. Thank you. Let me just, yeah. So I just want to show you one more demo before we close. This is the pod security policy. So Kubernetes, one of the, like I said, one of the things I was talking about is the admission control. And a very important admission control plugin is called the pod security policy. Now, the pod security policy is one of those admission control plugins that can help you secure your workloads in a quite a comprehensive way, right? So even if you're deploying insecure apps, if you do a good job of pod security policy, it can restrict the attack surface by quite a bit, and that really helps, right? So pod security policy, you can do a lot of stuff in terms of the pod security policy. You can deploy runtime protections. You can use container protections like AppArmor and SecComp and so on. So the idea of running a pod security policy is that you can essentially set the security parameters for each and every container runtime related parameter that is running on your cluster, right? So you can say that, hey, you know what, whenever you're running a container on this cluster, it has to be a non-privileged container. It has to have this particular runtime policy loaded into the container. It can only do read-only access to this particular file system. You can't do privilege escalation. You can't. So you can set up a whole bunch of policy rules which you define like so. So you can say that, hey, you see that this is just an example. Of course, I'm just giving you an example. So in this case, you're setting up a bunch of runtime security policies that say, you know what, deploy these runtime protections in the form of annotations. Privileged is set to false, which means that you can't run privileged containers that have all access to all different types of Linux syscalls and capabilities, right? You can't do that. Drop capability is set to all. Volumes. So it says that, hey, you know what, whenever this container is running and when there needs to be a volume mount, the volume mounts can only be to these specific volume mounts and nothing more. It's not running with host network privileges. It's not running with host IPC privileges. You can see that you can really specify a lot of very granular rules when you're running a container. So a good pod security policy is definitely something that you should be looking at. And tools like Kube Audit can actually help you create a pod security policy as well. So you can just load your YAML manifest, and it will tell you that, hey, based on your YAML manifest, this is what I feel is a good pod security policy for you. So it's pretty cool. You can auto-generate some of this stuff without having to do a little bit of the hard work, right? So some of this you can automate. Right, so I'm going to do my last demo before closing today. I'm going to, this is going to be my pod security policy demo. And I'm going to kind of set up my cluster from scratch, just to give you an idea. So I'm going to set up my cluster. This is me setting up my cluster from scratch. So let's look at, while the cluster is being spun up, let's look at the pod security policy, right? So I'm deploying the same app, by the way. Remember that previous app that we compromised and completely lateral moved into the cluster? The same app, right? I'm not changing that app. I'm not making it more secure. It's except that I'm adding a pod security policy, right? So let's look at what I'm doing here. And this pod security policy, I'm declaring inline. I'm not declaring it across the cluster. I'm just declaring it for that one specification. So in this case, I'm setting up a bunch of runtime protections, and I'll talk about this in a little bit. But more importantly, I'm ensuring that, hey, you know what, this is not running with root privileges. This is running as user ID 10001. So UID 10001, right? So it's not running with UID 0, which is obviously a bad thing. Must run as non-root is set to true. All of this is set to true. You see that I've dropped all of these dangerous Linux capabilities. So things like I can't do raw network packets. I can't do chown. I can't do all of these different Linux capabilities are now not available to my container. Privileged is set to false. Read-only root file system is set to true, which means that it's only read-only. You can't write stuff to the file system anymore. Remember last time, the reason we were able to privilege escalate was because we were able to drop a shell, which means create a file on the file system and then access that, and then make that file, execute that file and get it to reconnect back to our shell. That's not going to happen largely because we have a read-only. I mean, in some cases, not going to happen because we have a read-only file system. There are other ways to get that to work, but in this case, that's not going to work. And we've also set up some resource limitations. We're saying that, hey, you know what? The limit on this pod's consumption on the memory of that particular node is only 512 meg, nothing more than that, right? So you can actually set up all of this, and you can make your pod much more security focused, right? So in this case, that's what I'm doing. Now my cluster seems to be up. Get nodes. Yeah, my cluster is up, and I'm going to deploy my slightly more secure, although still insecure application, right? So the next thing I'm going to do is I'm also going to deploy my AppArmor policy. So AppArmor is a runtime security policy for Linux. It actually works on Linux. It also works on containers, right? So you can deploy AppArmor on your Kubernetes cluster. On that in this case, I'm deploying it on a particular pod that says, you know what, deny access to the app directory to write to the app directory. We are running our app on the /app path of our app directory. So it does not allow me to write. Does not allow me to write to the temp. Last time, if you remember, I uploaded my shell to the temp directory. It does not allow write privileges to the temp directory. Also denied etc password, etc shadow, access to all of that stuff. Access to home is also been denied, right? So I've just added that as an additional runtime protection policy. So let's deploy our cluster, our pod to the cluster. I'm going to parse the AppArmor policy, and I'm going to deploy our pod to that cluster. That's it. So a few things we did a little differently from previously. First of all, we've not deployed this pod with a lot of privileges. We have created a service account, and this service account only has access to a particular namespace. So even if this pod is compromised, this container is compromised, the blast radius of this is only restricted to this namespace called PSP. It does not go to the entire cluster. The entire cluster does not have compromise, right? So even if it's compromised, only that one namespace within that cluster may be compromised, right? So the blast radius of the compromise is immediately limited, right? So that's what we've done as well. So aside from the pod security policy, we've also kind of hardened up a little bit of the role-based access control here. So let's see if our pod is actually running in that namespace. Yeah, it seems to be running just fine. Now I'm going to exec into the pod and try and do what the attacker did previously, right? I'm not going to repeat the same set of steps. I'm just going to try, excuse me, and do what the attacker did. So I am going to exec. So this is me accessing the container itself using the exec command. This is accessing the container. Now let's try and create a file, right? So this is the files that I have. This is my app environment itself. So let's say I do touch shell /temp. That's what I did, right? Temp shell dot. I can't read-only file system. Remember, we added that runtime protection that it's a read-only file system. So let's say I try and do ping google.com. It doesn't work because I don't have raw socket privileges. I can't start. I don't have raw socket privileges. That's been restricted by my app or my pod security policy. Let's say I try and cat etc password. I can't because again, my AppArmor policy does not allow that to happen. So this way, I'm able to reduce, even though the application is still vulnerable. It still has the same vulnerability. I'm not even patched the vulnerability, but because I have a reasonably good pod security policy, I'm sure there are ways around this as well. I'm sure if you sit on this and start to look at evasion opportunities, you will find some, but definitely it's much, much lower than it was before. Right? So that's something that a good pod security policy can do. So yeah, so this is just an example of a pod security policy. But again, like I said, Kubernetes has a plethora of different security controls. You can use different controls. You can use encryption providers. You can use a lot of third-party security tools to help you with your Kubernetes journey itself. So it's really powerful. And so in conclusion, what I want to say is that if you think about Kubernetes, the biggest thing you have to think about is misconfiguration and access privileges. Those two are the usual hotspots in where you'll find issues. And the good chance is that if your payload, if your workloads are vulnerable, there's a good chance that that could escalate across the cluster. So definitely think about both these options before you deploy or get very deep into your Kubernetes deployment. Make sure that you have all of these things set up before and then start your deployment. Definitely look at automating your controls and learning more about the Kubernetes ecosystem if your organization or your company is doing more Kubernetes stuff in the future. So that's something I have to say. But yeah, that's it. I'm done with my talk, and I'll be happy to take any questions if you have at this point.
That's excellent. Thank you. So